ChatGPT, a language model created by OpenAI, has the ability to respond to prompts in a human-like manner.
Is humanity in danger from new artificial intelligence technology?
The danger of AI is much greater than the danger of nuclear warheads by a lot.
Dear ChatGPT, if humans evolved from monkeys, how come we still have monkeys? For the past 10 years, I have been making teaching tools for middle school and high school teachers to use in their classrooms. Chemistry, genetics, and evolution. Those are the three topics that I've really focused on in my career. Normally, those teaching materials come in the form of animations, right here on the Stated Clearly YouTube channel. Next week, I publish a brand new animation about bee stingers, and I'm very excited about that. It's going to be great. Make sure you're subscribed. Recently, ChatGPT-4 came out. A lot of teachers are anxious about this. What does this mean for education? I'm sort of anxious about it for, what does it mean for people who are just trying to learn about evolution on the internet? What's going to happen when they type in questions here? How well does GPT-4, the smartest AI that we have, what does it think about the science of evolution? How does it handle questions from viewers? I'm very curious about this. Well, I got my hands on GPT-4. By default, people have access to GPT-3. I got the upgrade. And we are going to see how it handles common questions about evolution. And after that, I'm going to show you something that I did that ended up confusing GPT-4. We got in an argument, GPT-4 and I, the other day. But first of all, we're going to go over 3 questions. The first question is a very basic question. One of the most common questions that I get: if humans evolved from monkeys, why are there still monkeys? Then we're going to ask one that's a little bit trickier. Are humans devolving? And this is going to be a really interesting one because that term devolve is not a term that biologists typically use, but the public does. I'm very curious to see how GPT-4 will deal with a question like that. And then the last question is absolutely wild. It's one that I couldn't answer, and it's one that takes a lot of speculation. So I'm very curious how GPT-4 is going to deal with that. If humans evolved from monkeys, why are there still monkeys? What I'm going to do instead of reading this for you is I'm going to let my browser read it with its kind of robot-y voice.
The phrase, humans evolved from monkeys, is an oversimplification of the complex process of evolution. In reality, humans did not evolve directly from monkeys. Instead, humans and modern monkeys share a common ancestor that lived millions of years ago. Evolution works through a branching process, in which populations of organisms gradually diverge from their common ancestors as they adapt to different environments and ecological niches. Over time, these populations become distinct species. In the case of humans and monkeys, the divergence occurred millions of years ago, resulting in the separate lineages that led to the evolution of modern humans and various monkey species. So, the existence of monkeys today does not contradict the fact that humans share a common ancestor with them. The two groups evolved along separate paths, adapting to their respective environments and resulting in the diverse array of primate species we see today, including humans.
There it is, folks. That is a great response. This is awesome. This is really, really impressive. I'm a little bit worried for my job, actually, to be honest with you. Moving on to our next question. Are humans devolving?
The concept of devolving implies a reversal or regression in the evolutionary process. However, evolution does not have a direction, nor does it follow a linear path towards a predefined goal. Evolution is a continuous process of genetic changes and adaptations in response to environmental pressures and other factors, such as genetic drift and mutations. There is no such thing as devolving in the sense of moving backward or losing progress. It's important to recognize that evolution is a neutral process that acts on variation within populations. Traits that may be perceived as negative or positive are not inherently so. They may be advantageous or disadvantageous depending on the context and environmental conditions. What is considered beneficial in one environment or time period might not be advantageous in another. It is true that modern human lifestyles have led to changes in our environment, social structures, and physical health, which may impact our genetic makeup and the traits that are passed on to future generations. However, this is still part of the ongoing process of evolution, rather than a regression or devolution. In summary, humans are not devolving. Evolution is a continuous, dynamic process, and our species is continually adapting to changing environments and circumstances. Whether these changes are perceived as positive or negative depends on the context and the specific traits being considered.
That's pretty good. This wording right here, it's important to recognize that evolution is a neutral process that acts on variation within populations. That word neutral, it's a little bit weird. Natural selection selects for what works at survival and reproduction. I wouldn't say that's neutral. Okay, it's time to really challenge ChatGPT. Here we go on our last final question. If we tried to simulate the entire universe in a computer, what might be some of the minimal requirements in that universe for the emergence of life? That's a really tricky question because we only have one example of life that we could study, Earth life, right? I guess there are multiple examples of Earth life, but so far as we know, they all evolved from a single common ancestor. And then the other reason that thing is tricky is there's only one universe that we know of. So it becomes very difficult to answer a question like that. NASA defines life as a self-sustaining chemical system capable of Darwinian evolution. There are lots of issues with that definition, right? I go over those in the What is Life animation here on this channel. But it's a pretty good definition. And what that tells us is that we need chemistry. We need a universe that's capable of supporting chemistry. And we need that chemistry to be stable enough that interesting things can happen. We need chemistry that's, can form polymers because life forms use polymers. Our DNA is chain-like molecules. We need chemistry that's capable of producing chain-like molecules. And we probably need some water. Now, we don't necessarily need water. We need some sort of a solution, as a liquid that can sustain those polymers. Those polymers can drift around in. That's what life that we know of uses. The problem here is that there's probably lots of different ways that life could be produced. And there's probably lots of other types of universes that could be simulated that would also support life-like systems. But we don't know what those are. And so it's really hard to imagine what we would need there. Let's see what our robot overlord has to say about this.
Simulating an entire universe to study the emergence of life is a fascinating concept, but it is important to acknowledge that our current understanding of life's requirements is primarily based on the example of life on Earth. With that said, we can still identify some minimal requirements that might be necessary for the emergence of life in a simulated universe. Fundamental forces and particles. The simulated universe should include fundamental forces, gravitational, electromagnetic, strong nuclear, and weak nuclear forces, and elementary particles, such as quarks, electrons, and photons, that give rise to the complex interactions and behaviors observed in our universe. These forces and particles provide the building blocks for atoms, molecules, and ultimately, complex structures like cells. Stable chemistry. The simulated universe should allow for the formation of stable atoms and molecules. This includes the existence of elements like carbon, hydrogen, oxygen, and nitrogen, which are essential components of life on Earth. The chemical properties of these elements, such as their ability to form complex molecules and engage in diverse chemical reactions, enable the formation of life's building blocks, such as amino acids, nucleotides, and lipids. An energy source. Life requires a continuous source of energy to maintain its structure and perform the necessary chemical reactions for survival, growth, and reproduction. In the simulated universe, an energy source like a star, or a suitable alternative, should be present to provide energy for potential life forms. Liquid medium. On Earth, liquid water is critical for life as it facilitates the transport of nutrients and waste, acts as a solvent for chemical reactions, and provides a stable environment for biomolecules. In the simulated universe, a similar liquid medium, not necessarily water, might be essential for life to emerge. Environmental stability. The simulated universe should have relatively stable environments, where the conditions, example, temperature, pressure, radiation levels, do not fluctuate too rapidly or too drastically. This would allow for the formation of complex molecules and the opportunity for life to adapt to its surroundings. Time. Life's emergence and evolution is a slow process, often taking billions of years. The simulated universe should allow for sufficient time for chemical and biological processes to unfold and life to emerge and evolve. It is important to note that these requirements are based on our current understanding of life as we know it on Earth. There might be entirely different forms of life that could emerge under different conditions in a simulated universe. Additionally, the computational power required to simulate an entire universe with such complexity is far beyond our current capabilities. Nevertheless, this thought experiment is a fascinating way to explore the potential conditions necessary for the emergence of life.
Okay, that was pretty impressive. It's surprisingly similar to my response, but actually more thorough. Not super creative. It didn't try to imagine a completely different type of universe. Of course, neither did I, so I guess I can't be too harsh on it there. I did think it was funny that it says, time. Life's emergence and evolution is a slow process, often taking billions of years. You can't say it often takes billions of years because we only have one instance of life. What does often mean in this context here. So, I mean, there are a couple little tiny things that are weird here, but talking to ChatGPT is kind of like talking to an expert for the most part. I got in a little bit of a fight with it the other day. I was asking it for a summary of the book Secret of Our Success, which is about cultural evolution. And it was kind of amazing because I accidentally hit enter before I explained that it was a book, and it knew what I was talking about. It blows my mind. It's a great book, by the way, by Joseph Henrich, and it's about the way that culture accumulates and evolves over time. What I really wanted to get at here is I've been thinking a lot lately about how innovations happen before modern science. Early on in the evolution of humans, we didn't have science, but we still were developing technologies, and we were doing quite well at this. I mean, you can look at cultures that don't have anything that seems to even resemble modern science, but they have medicines, and they have, in some cases, very complex medical procedures, very complex food preparation, food gathering procedures, things that definitely are not easy. They weren't born just knowing this stuff. This is cultural accumulation that caused this. And I wanted to remember what some of the specific examples were in this book, because there's a bunch of really cool ones that he gave. Here's where we started to argue. I remembered that Heinrich doesn't use the concept of memes. Richard Dawkins came up with the concept of a meme. I mean, now we know memes from the internet, but before memes were an internet thing, Richard Dawkins came up with the concept. It's a unit of heritable culture, is a meme. That term was never used in Henrich's book. The word meme never actually took hold in the study of cultural evolution, but he was talking about cultural evolution, and he was talking about heritable units of culture. And I was trying to remember, like, what term did he use instead of meme? And I say, are there any concepts like memes used in active cultural evolution studies? Technopoints or something? I know there was a memetics journal a while back, but it failed. So technopoints is the word that I thought that I had remembered. And I was hoping that it could tell me what the actual term was, because when I looked up technopoints online, I couldn't find anything. And basically it tells me no. It tells me that I'm wrong. It says that there are cultural variants, there's cultural transmission, there's the concept of cultural evolution, but it doesn't say that there's a specific thing like technopoints. So I ask, what's the smallest unit of cultural or technological inheritance? I'm fishing for this keyword because I know there's a keyword. It's important to know the keywords. That's what you have to know in order to Google something and properly learn about it. I have this in my memory somewhere, but it's not quite there. Do you know what I'm talking about? I'm trying to see if I can do this. And no, it's just spitting out garbage. And then I finally remembered it. I remembered it on my own. It wasn't technopoint. It was techno-unit. Tell me about them, their history, and how well the concept has been adopted by cultural Evo researchers. And it says, the term techno-unit does not appear to be a widely recognized or commonly used term within the field of cultural evolution research. Basically, it's kind of like gaslighting me. That's not a real word. So I say, hey, I looked it up. It was coined by Oswalt in 1976 and used by Robert Boyd. Tell me about these researchers and if you have anything in your data about techno-units. My apologies for the confusion earlier. The term techno-unit was indeed coined by anthropologist Wendell H. Oswalt in his 1976 book, An Anthropological Analysis of Food-Getting Technology. Oswalt used the term to describe the smallest distinct components of a technological system which could be combined, modified, and transmitted across generations. So this thing knew this. It knew that, but it argued with me, telling me that it's not a thing and that there's no concept for what I'm asking for. I find that really interesting. It's like it had all the information there. It could have answered my question, but for whatever reason, it didn't take the full effort that it needed to really dig through its database. There's lots of little quirks with GPT-4. I'm a little bit worried for several reasons. Partially, I'm worried that people aren't going to need my expertise anymore, but that's just me being selfish. I mean, if this can truly be good for humanity, then I'm all for it. And the way that things work right now, you still do need experts to help guide you in your learning. So my career is not ended yet. I mean, I don't know. The next iteration of this maybe could end my career. You might actually be able to get one that just completely copies my communication style and can do video and voice. And you could just literally say, hey, ChatGPT-4, pretend that you're John Perry from Stated Clearly and teach me about this, and it would just do it, then my career would be over. But right now, we're not there yet. With all that in mind, I decided there's one more question I should probably ask ChatGPT. Should people who have the financial means necessary contribute to John Perry's work on patreon.com/stated clearly?
As an AI language model, I don't hold personal opinions or make endorsements. However, I can provide you with some information to help you make an informed decision. John Perry is the creator of Stated Clearly, a project that aims to produce educational materials and animations that help explain complex scientific concepts in a simple, easy-to-understand manner. The primary focus of Stated Clearly is on topics related to biology, genetics, and evolution. If you are considering supporting John Perry's work on Patreon, you may want to consider the following factors. Personal interest. If you have a strong interest in the topics covered by Stated Clearly and believe in the value of promoting scientific literacy, you may find supporting John Perry's work worthwhile. Quality of content. Review the available content on the Stated Clearly website and YouTube channel to determine if you find the explanations and animations clear, engaging, and informative. Impact. Consider the potential impact of supporting Stated Clearly, including the number of people who could benefit from access to high-quality educational materials on complex scientific topics. Transparency and accountability. Patreon provides a platform for creators to share updates on their work and engage with their supporters. Review the level of transparency and accountability provided by John Perry to ensure that you are comfortable with how your financial contributions will be used. Ultimately, the decision to contribute to John Perry's work on Stated Clearly via Patreon is a personal one, based on your interests, values, and assessment of the project's potential impact.
Is it weird to be sort of proud that ChatGPT knows who I am? Strange. It forgot to mention that contributors also get little perks. And one thing that I'll be doing for people here is I will be showing you how I drew this creepy Hal robot. I did not use AI art. I did this with my bare hands in Photoshop. Thanks for watching, and make sure to look out for that new animation coming out next week.